We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is based on the applications of the derivatives. And this question has come from the section Differential Calculus. The given question is, if y of x is equal to x power x, where x greater than 0, then d square x by dy square plus 20 at x is equal to 1 is. So now we are given y as a function of x, and it is given as x power x to the power of x, where x is positive. Required to find the value of d square x by dy square plus 20 at x is equal to 1. This is our given question. Let's now discuss the solution of the problem in detail. We have y, a function of x, given as x power of x, that is equal to x power x square, where x is positive. Right. What is that we want? We want d square x by dy square, but we have y of x, which is a function of x given. So we normally find its first derivative and second derivative, that is d square y by dx square. So, but we want d square x by dy square. So, what is the relationship between second derivative of y with respect to x with the second derivative of x with respect to y? So, if y is equal to y of x is any differentiable function, then we have a relationship between the second derivative of y with respect to x and the second derivative of x with respect to y. What is that? D square y by dx square is equal to minus dy by dx whole cube into d square x by dy square. So, from this you can find d square x by dy square, provided if you know d square y by dx square and dy by dx. So now it's now easy. Now we want this first derivative. To differentiate this one, we take logarithms on both sides. Taking logarithms on both sides, ln of y of x is equal to x square ln of x. Now differentiate with respect to x, we get derivative of ln of yx is 1 by yx. Yx with respect to x is y prime x. That is the first derivative, that is dy by dx, is equal to, we use the product rule for differentiation. First function x square into the derivative of the second function, the derivative of ln x is 1 by x, plus second function ln x into the derivative of the first function, that is the derivative of x square is 2x. So we got this one. Cancel this one. X greater than 0, no problems will come. So x square by x is x, and send this yx, which is sitting in the denominator on the left hand side, to the right hand side. Then you will get y prime x is equal to y of x multiplied by, in brackets, x plus 2x multiplied by ln of x. And differentiate once again. We want d square y by dx square. So differentiate with respect to x on both sides, y double prime x is equal to the derivative of the first multiplied by the second function plus first function into the derivative of the second. We have done it. We have done it here. So now in this x cancels, we'll get 1. So you will get this is equal to y prime x into x plus 2x into ln x plus y of x into 1 plus 2 times 1 plus ln of x. We can still further simplify. This 1 plus 2 is 3, 3 plus ln x you can write in the bracket. So everything is same. In the last bracket we have written y of x into multiplied by 3 plus ln of x. Agreed. So we got a dy by dx and a d square y by dx square. We continue in the next slide. So we have y of x, its first derivative and the second derivative, what we have done in the last slide. Agreed. We have that relation, that is d square y by dx square is equal to minus dy by dx whole cube into d square x by dy square. D square y by dx square is y double prime x is equal to minus y prime x whole cube into d square x by dy square. Put x is equal to 1. So you'll get put x is equal to 1, y double prime at 1 is equal to minus y prime at 1 whole cube into d square x by dy square to be evaluated at x is equal to 1. Now what are these values? What are and y double prime we know, y prime we know, y we know. So now go back to y prime x in this, put x is equal to 1. So we'll get y prime 1 is equal to y of 1 into x is 1 plus ln of 1 is 0. But what is y of 1? So we go back, y of 1 is equal to 1 power 1, that is 1. So come here, y of 1 is 1, 1 into 1 is 1. So y prime 1 is 1. Agreed. And go to the y double prime x. So y double prime, in that x is equal to 1 you substitute, y prime 1 multiplied by 1 plus ln of 1 is 0 plus y of 1 into 1 plus 2 into 1, that is 3. This is already we have done is 3. 3 plus 1, 4. So we got 4 is the y double prime 1 is 4. So substitute here, y double prime 1 is 4 is equal to minus y prime 1 is 1, 1 cube is 1 only, minus d square x by dy square at x is equal to 1. Thus we got d square x by dy square at x is equal to 1 is equal to minus 4. What is that we want? Required to find the value of d square x by dy square plus 20 when x is equal to 1. That is d square x by dy square at x is equal to 1 plus 20 is equal to minus 4 plus 20, that is equal to 16. Thus d square x by dy square plus 20 at x is equal to 1 is equal to 16. That's your answer. That is the detailed discussion of the solution of the problem from the subsection applications of derivatives from the differential calculus. Now, the key to the success of proving this or solving this question is this concept. That is the relationship between d square y by dx square and d square x by dy square when y is a differentiable function of x. If you know this, then the problem is easy. So if you do not know, please learn this derivation or else you remember this relationship. So that is the detailed discussion, and I am sure that you have understood the solution of the problem, and I wish you all the best. Thank you.